Amazing photos delivered by NASA's James Webb Space Telescope this year have created a tremendous amount of interest in the great beyond. While not as public, there's work being done locally and elsewhere probing so-called ripples in space-time. And as Bryant McCrae discovered, it's research that would make Albert Einstein proud.
Let us take you to a place far, far away. 32 billion light years to be precise.
We're doing something that's never been done before.
To infinity and beyond.
We're trying to answer fundamental questions about the universe.
But before we can get to those questions, let's start a bit closer to home, Milwaukee. More specifically, the halls of UW-Milwaukee, where out-of-this-world research is taking place.
We're understanding things like how stars evolve, how galaxies evolve.
This is Sarah Vigeland. She's an assistant professor of physics at UWM. Vigeland is also a researcher on the Nanograph project. You might be wondering what nanograph means. This is it.
It stands for the North American Nanohertz Observatory for Gravitational Waves.
An international science project spanning 2 decades, answering and forming questions about something we all know and love, gravity.
So gravitational waves are a really important prediction of general relativity. So it predicts that really massive objects will create these ripples in space and time.
A key factor in this experiment, looking at black holes.
So this is what happens when a star gets a little too close to a black hole.
Black holes are really the most extreme objects in terms of gravity, and that is why they are kind of scary but also kind of cool.
It looks like this is from...
Along with black holes, these Milwaukee scientists are also gathering information about pulsars, essentially a dead star packed full of information.
This is a pulsar. This is radiation that's going around and around.
The longer you observe and the more pulsars you observe, the more sensitive you get to gravitational waves.
As the gravitational wave goes by, it slows down the clock,
forming a bigger picture about our universe.
We can study not just the stars and planets in our own galaxy, but how galaxies form and evolve throughout cosmic time.
This work isn't done alone. Research and data is being gathered from all across the world, working with roughly 40 institutions.
And we primarily have been using the Green Bank Telescope in West Virginia and Arecibo Observatory in Puerto Rico. We also take data with the Very Large Array in New Mexico and CHIME in Canada. And that's just us.
Equally as exciting, some of the earth-shattering research is being done by scholars at UWM, some of whom thought a career in astronomy was science fiction.
It didn't seem like something that people could just go out and do.
This is Sparrow Rock, an undergraduate student at UWM, studying physics and computer science. She is just one of the students who works hand in hand with Vigeland looking for the unknown.
There's opportunity to ask lots of questions about what does matter do when it gets so dense? We think that it's made of really tightly packed neutrons, but we don't know all the answers.
But it's the not knowing which is half the fun for these scientists.
It's great to see things that you know are there and that you expect to see, but it's even more exciting to see something and say, I wonder what that was. That was really weird.
The work coming in at a hefty price tag. The National Science Foundation awarding UWM $17 million in grant funding for the next 5 years. A price scientists say is a drop in the bucket for what can be accomplished.
One of the leading places in the world to study gravitational waves. I think people in Milwaukee should be very proud that we're contributing to science in this really important way.
Cheese curds, beer, brats, and now...
space. Yeah, what a mix, right?